for number 4, if we look at this one, we have e to the x times cosine of 2x. So we need to figure out what our u and dv are going to be. And we want to keep in mind what we get when we take the derivative of these, or antiderivative, to figure out what's going to be best in the long run. So e to the x, whether we set u as e to the x or dv as e to the x dx, either case, we're going to get e to the x, because derivative of e to the x is e to the x. Antiderivative of e to the x is e to the x. So really, that doesn't make a difference where we put that. Now, cosine of 2x, if we put that in for u, derivative of cosine of 2x, we use the chain rule. We'd have negative sine of 2x times derivative of 2x, which is 2. So negative 2 sine of 2x. Not too bad. If we set cosine of 2x dx as our dv, to do the antiderivative, we're going to be using u substitution. Not too tough, but probably a little bit more work than the chain rule part. So I'm going to go ahead and I'm going to use cosine of 2x as my u, because taking the derivative, a little bit easier, less work kind of to do that. Really, I think either way we do it, it'll work out fine for this problem. So dv is going to be e to the x dx. So like we said, derivative of cosine is negative sine, and then derivative of 2x is just 2. So we have negative 2 sine of 2x dx. And then v, if we do the antiderivative of e to the x dx, we just get e to the x. So for this one, we end up with u times v, so e to the x times cosine of 2x, minus antiderivative of v du. So we've got this negative 2 in here. I'm going to make it positive 2 since we're subtracting. Keep that 2 on the outside. And then we have e to the x sine of 2x dx on the inside. Well, this integral not looking a whole lot better than the last one, right? We still can't use regular u substitution, can't just evaluate it as is. So we're going to try integration by parts again. So this time u is sine of 2x, and dv is e to the x dx again. So du, sine of 2x, derivative of sine is cosine, and then derivative of 2x is 2, so we get 2 cosine of 2x dx, and then v is just going to be e to the x. So the first part here stays again, e to the x, cosine of 2x, plus 2 times this whole thing, right? That 2 is outside the integral. This integral is going to be replaced with that integration by parts formula. So we have u times v, e to the x, sine of 2x, minus antiderivative of v du. So I'm going to keep that constant out again. And then we get e to the x, cosine of 2x dx. Not looking any better. But what is it looking like? That integral we just end up with now. Does it look familiar? It's the original, right? In this case, with e to the x, antiderivative of that always being e to the x, and then cosine and sine, those just kind of alternating, we end up like getting the same thing that we started with inside this integral. So it's not a cruel joke. It's not like one that we can't figure out. We just have to use a little different approach. So what we're going to do here is try and get this to the other side. I haven't been writing this on the left side, but really we've got this on the left side of our equation. Antiderivative of e to the x, cosine of 2x dx equals this whole thing. So if we can get this one over here with this one, right, they're like terms, so almost treating it like a big variable, we get it over there like terms, and then divide, we can get this all by itself. So the first step in doing that then is to get that out of the parentheses on this side. So we have e to the x cosine of 2x plus 2 e to the x sine of 2x minus 4 times the antiderivative of e to the x cosine of 2x dx. So like I was saying, I want to combine these like terms. We've got this integral and this one that look the same, but this has the negative 4 in front. So what we're going to do is add 4 times this integral to both sides. So now I have an extra x in there. So we end up with 5 times the antiderivative of e to the x cosine of 2x dx equals e to the x cosine of 2x plus 2e to the x sine of 2x. And then all we have to do to solve this, remember this is what we're trying to figure out, all we have to do is divide both sides by 5. So the integral that we originally started with is going to be equal to this whole thing divided by 5, or we could write it as like 1/5 e to the x cosine of 2x plus 2/5 e to the x sine of 2x. And we need to remember the plus c. So that's one we need to keep in mind. Easy to forget on this problem.